Peterson. Well, I met with them about 2 hours ago. You know, I'm not going to stay for your seminar. I'm going to jumpstart on spring break. It's his kids' spring break next week, so they're going skiing. He said, well, I think you know all this.
Yeah. Does anybody want a handout for the talk? Yes, no? Hey, take some handouts.
Oh, hello.
Are you ready for this?
Yes, maybe.
Yeah, go ahead, take some handouts. Yeah. Help yourself to refreshments as well. Good afternoon, everybody. Welcome to the WRS seminar. Today, we're pleased to have John Bilotta, who is a research specialist with the University of Minnesota's Water Resources Center. He leads the Minnesota Stormwater Research and Technology Transfer Program, including leading the Minnesota Stormwater Research Council. And he's going to talk to us today about stormwater research and technology transfer. Prior to joining the center, he worked for more than 21 years as an extension educator. He was in the area of water resource management and policy. He had a joint extension educator appointment with the Minnesota Extension and Sea Grant programs. John has a bachelor's degree in environmental studies and natural resources and an MS in soil science with a focus on fertility and nutrient management, both of them from the University of Minnesota. And we're very pleased to have you here today and are interested in hearing more about your research. Thanks.
Thank you.
Well, good afternoon, everyone. I'm happy to be here and share some about our program. In reflection of coming to seminar today, I thought I'd begin with a lot of what I will talk about is non-point source pollution prevention and remediation. And I think back about where some of this started for me, and it started in this very room with soil chemistry with Dr. Ed Nader many years ago, and trying to understand what cation exchanges were and all that. And it started right here. So we're going to talk a little bit about that connection today. So I'm going to talk about the program that I lead over at the Water Resources Center, which, if you don't know, is right over here in McNeil Hall. Talk about the Stormwater Research and Technology Transfer Program, which is really about advancing applied science, not only here at the University of Minnesota, but working with many partners across the state, other academic institutions, agencies, with the goal of preventing, minimizing, or mitigating the impacts of urban stormwater runoff. So the purpose of the program has four components. First of all, to accelerate accelerate research to improve best management practices that perform and develop new treatment technologies in terms of urban stormwater runoff. Conduct technology transfer or training and education. Third, to enhance the efficiency and effectiveness of stormwater management across the state. And then finally, to raise visibility and synergy among different efforts. What we're really excited about with the Stormwater Research Program is it's much broader and bigger than just the University of Minnesota. And one of the best traits of the program is that we have an advisory council that's called the Minnesota Stormwater Research Council. And it consists of practitioners and policymakers and professionals from all across the state working in urban stormwater management. And so the council comes together to help us inform some of the research that we do. And so the council works side by side with the program to help facilitate this research to move it forward, continually helping us identify new research needs about where we need to invest our time, talent, and money, assist in the coordination of these research efforts across the state, identify collaborations, obtain funding, develop what we call requests for proposals, review those proposals, and facilitate what we call technology transfer, which I'll tell you more about in a moment. The council itself, I talked about the makeup of it. The advisory board is actually 21 members that really help us make sure that our research is applied and can be used basically in Minnesota communities across the state. But before I go there, I probably should never assume we all know what I'm talking about. Urban stormwater runoff. One of the lessons learned in our program the last couple of years is you can't just say stormwater runoff. You have to say urban stormwater runoff. We're talking about that runoff from precipitation and snowmelt from the built environment, coming from impervious surfaces, streets, sidewalks, parking lots, rooftops, even compacted turf grass in some cases. All results in this runoff from the built environment. And what we ask ourselves as a group of researchers and professionals and practitioners is, does this urban stormwater runoff have impact? Does it have impact on our lives? Does it have impact on the community and the environment? And we broadly think about these impacts in terms of two factors. I call it the Q and Q, quantity and quality. The story starting in the upper left here is about flooding. It's about the quantity issue. Rarely is too much water a good thing. Localized flooding, impacts on homes, streets, those types of things. But there's also the quality aspect. The aspect of this urban stormwater runoff and its impact on human health, drinking water supplies, the aesthetics of our natural environment, which we value very high here in Minnesota, the health of our biota in our natural systems, our fish, our macroinvertebrates, our aquatic plants. We're also concerned because every gallon of stormwater runoff that flows through our community costs us money to manage. Pipes, concrete curbing, those types of things. And finally, Rooted way back in 1974 in the Clean Water Act, we can talk about a whole alphabet soup of regulations that really push us to be concerned and push us to action in terms of urban stormwater runoff. The impacts we also broadly categorize across 6 different types of pollutants when we're talking about water quality. Nutrients, including phosphorus and sediment, or phosphorus and nitrogen. Sediment itself is a pollutant, but we also consider sediment a carrier for other pollutants. Where erosion and sediment particles go, they also have with them other pollutants such as pathogens and toxic contaminants. Debris, including large debris like pop bottles and plastic jugs and cigarette butts and all these types of things that we think that we were recycling, but we're not. And finally, the 6th category of pollutant is actually heat. It's thermal. And you think about how the sun warms up all this impervious surface during the summer, and then we get a rainstorm. It changes the temperature of the receiving body by all this warm stormwater runoff. So we have increased quantity from impervious surface, and we have decreased quality.
John,
Yes.
do you include salts as one of those pollutants?
Yes, definitely. Chloride and salts would be in this. This is kind of an older slide, but we would probably put them within toxic contaminants, maybe under the nutrient heading as well. It depends how you consider chloride. So knowing we have these impacts, what can we do about it? My message over my career has really been couched in what I call the 3 Ps. In terms of minimizing our impact from urban stormwater runoff, we have the ability to implement plans. Those things would be like water quality plans, watershed management plans, city stormwater plans. They make all different types of these, right? Second, practices. These could be structural or non-structural practices that we put in the ground. And finally, the 3rd P is we have the power to implement new policies, regulations, ordinances that help us minimize our impact. The idea behind these practices is that we will decrease the quantity of urban stormwater leaving the landscape, slow the rate, and improve the quality in relation to these types of pollutants. How we approach urban stormwater management is a mixture of different types of practices that include infiltration, allowing stormwater to infiltrate or soak back into the ground, conveyance, pipes, ditches, curbs, storage, and then filtration. Really, the recipe for our success today in terms of minimizing impact from urban stormwater runoff has to include all 4 of these pieces. All right. So there's my 101 on urban stormwater runoff. The question that we ask ourselves as a program and as a group of professionals is, do we have unanswered questions when it comes to urban stormwater runoff? What do we wish we would know that would help management in terms of water management at the local level? In other words, what we've asked ourselves is, do we have research needs? And I won't go into this in detail, and I do have a flyer that I've made. That's this piece right here. And what we did starting in about the year 2017 is look at what are our information needs? What are our research needs in terms of urban stormwater management? And we came up with 8 broad categories of needs, and I'll let you read those in the pamphlet and on the screen yourselves. There's a lot of specificity underneath each one of these, but the point being is we identified high priority research needs for the state of Minnesota when it comes to urban stormwater runoff. How are we going to meet some of these needs? There comes, or there enters our Stormwater Research and Technology program. So I want to talk through a little bit what we've done with the program, which established itself in the year 2017. So the first thing we need to do is to conduct research. Well, we need money. Research costs money. And so back in 2017, we had received our first allotment of research money from the Minnesota legislature through the Clean Water Land and Legacy Amendment in the amount of $1.5 million for the biennium. If you think about investments in retirement accounts, our philosophy is you have to be diversified in your funding strategies. So we tried to leverage this money with other pools of research funding. And what we've been able to do is assemble funding from other sources that include watersheds, cities, even private businesses that have contributed to this pool of research dollars. So over these 2 years, we've assembled $215,000 in matching funds. So the story is we have about $1.7 million of funds that we can invest into research over this time period. What I want to do is give you a brief insight into some of the research going on, much of it led by your colleagues and professors here at the University of Minnesota, but not all of it. So I want to give you just a brief of some of the projects. Any one of these projects is a presentation by itself, but just to give you a sense of what we're doing in terms of urban stormwater research. So there are 11 projects that we funded in 2017 and 2018 involving more than 54 researchers. You know many of them. So I just selected out a few representative ones. I'm gonna go back to how I opened my presentation, talking about soil chemistry that I learned in this room from Dr. Ed Nader. What we know through research conducted here at the University of Minnesota, a lot of it by Andy Erickson, who's sitting with us here, is the ability of iron to capture phosphorus, one of our predominant pollutants. By the way, I've been often reminded by colleagues, when we talk about phosphorus as a pollutant, phosphorus itself is not a pollutant. It's a critical building block to our aquatic ecosystems. It's when it's in excess of amounts that it becomes a pollutant. We know that through soil chemistry, iron is one of these compounds that can trap and hold phosphorus. So one of the practices that was developed through research here at the University of Minnesota is something called iron-enhanced sand filters. Basically, we run urban stormwater runoff through a filter that has iron filings in it, and that iron starts to capture the phosphorus. The research that we're doing now is where can we locally find iron that will do this work well? The iron that's been used in these practices to date has traditionally come out of Chicago. And you think about Minnesota, one of the things that we know of is we have the iron range here. We have naturally occurring sources of iron. So this particular study is looking at what specific compounds within iron, what types of iron best absorb phosphorus. So this is an example of one of the projects. If you've been paying attention to urban stormwater runoff, you might have noticed that one of the practices that have proliferated across the state and across the country are rain gardens. We refer to these as bioretention basins. They use hydrology, plant, and soils to treat and absorb urban stormwater runoff and the pollutants that are contained in that. They've been wildly successful, but they are limited in terms of their impact and how they effectively operate. They need to control what we call the incoming gross solids into these rain gardens or bioretention basins. So this is actually work that, again, Andy actually has been on the forefront of looking at what type of pre-treatment works best for rain gardens in terms of capturing what we call sediment and gross solids. Sediment particles, those pop bottles, big organic matter like leaves, twigs, tree seeds, those types of things. So Andy and his crew tested a number of different pre-treatment devices with rain gardens. So we can see a few of them here on the screen. I'm not going to go into all of these, but this gives you a flavor for some of the different types of things that we're testing. The other part that I want to emphasize is most of the research that we're funding through our program happens out in the community. It's what we call applied research. So this work is actually happening, in our case, bioretention or rain gardens that are actually out in communities within cities. Here's another interesting study. My first degree was in soil science, nutrient management here from the University of Minnesota. I did my fair share of soil sampling with GPS 20 years ago. We're trying to map soil fertility across crop fields, right? Trying to do the same in terms of urban stormwater management, in that we're trying to map stormwater infrastructure, pipes underneath the ground. Believe it or not, some of our GIS and GPS matching, you have to think of stormwater pipes underground when they go from one city to the other. They don't quit, right? They just keep going to the receiving body. What we've discovered is at different city boundaries, municipal boundaries, the GPS maps don't line up. We lacked a GIS protocol in terms of mapping stormwater infrastructure in communities. So this is a study that we're funding that will be done here actually in less than a month, looking at establishing GIS standards, mapping standards, how we map stormwater structures across Minnesota communities so they're consistent. We're not just investing in technical solutions either. Part of the solution involves people, it involves policy, it involves policymakers. So another interesting research that we're funding is looking at what inspires people to minimize their pollution. What motivates people to help us manage stormwater so that it makes less of an impact on communities. So this is work that we funded May Davenport out of Forest Resources, looking at what inspires policymakers and residents to take action in stormwater management. So this is a social science aspect of stormwater. I think this might be my last example, 11 different projects. You're getting a sense of the variety here. The University of Minnesota has been in the forefront of looking at research, what we call pollution prevention. And shortly, in a few weeks, you're gonna start observing street sweepers out on the streets of Minnesota communities. Everyone's seen a street sweeper before, right? The misconception here is that we go out and sweep streets. Now you say that fast 3 times. We sweep streets to make them look pretty. That's not why we're doing this. We sweep streets to remove pollutants before precipitation storm events have a chance to put those pollutants into the urban stormwater stream, in the pipes and out of sight. Street sweeping is a stormwater pollution reduction strategy. The University of Minnesota has done a lot of research in what type of sweepers work the best. How frequently should you sweep? What type of streets have more pollutants than others? All of this idea of coming up with a better strategy for sweeping streets, because you think city of St. Paul here, there are thousands of miles of streets. We can't sweep them all. So some of the research that's been done prior to this is looking at the effective strategies for street sweeping, and we've actually developed an enhanced street sweeping protocol and system. The last piece of the research that we're funding that will be completed this year is helping cities get a credit for that street sweeping strategy within what we call their MS4 permit, their regulation. We all would like pollution reduction because water quality is important to us, because of human health or aesthetics, wildlife, fish habitat, all that. But for a city level, it really comes down to they have to maintain a permit, they have to meet the regulation. And so if we do some of these creative practices and we invest in research, part of that is proving how it can help them meet their permit for water quality. Again, I want to emphasize that these types of applied research projects do not necessarily happen within this building, within the walls of the university, but out in communities. So our street sweeping study occurs in Minneapolis, Roseville, Shoreview, and Forest Lake. And that's just some of them. We have a number of other projects, some of them having to do with manholes in the street, looking at nutrient and PAH storage in stormwater ponds, and also the dynamics of pathogens in stormwater reuse systems. And actually, Professor Ishii out of CFANS is doing that. Yes, sir.
Is the Minneapolis adopted drain program one of the ones that you guys have initiated?
So the question was the Minneapolis Adopt the Drain program, is that a part of any of our research studies? No, it's not. There's been limited research on that, but that's a citizen resident-based education campaign, but we have not funded any research into that. And I'm a participant in that program too. I've adopted 2 of my storm drains in my neighborhood. The other piece of the program I do want to mention, this is the Stormwater Research and Technology Transfer Program. And the latter half of that is basically, research is only as good as it is if it can be used by practitioners, policymakers, and professionals in the field. So we put a high emphasis on not only doing the research, but making sure it get in the hands of people that can use it, with the goal of minimizing pollution and runoff from our built environment. So some of this happens in field certification workshops that the university leads. Other parts of this research are integrated into coursework that you may have participated in here at the university. One of the technology transfer components that we offer is something called the Minnesota Stormwater Seminar Series. This is a professional seminar that we do monthly that offers not only national experts, but some of our work in stormwater research. If you haven't had a chance to participate in one of these seminars, they occur monthly. About the third Thursday, we have our schedule on our website. I encourage you to take a look at those. Our next one is March 12th, by the way. I think that's next week, on stormwater policies across the United States. So believe it or not, all that was 2017 and 2018. 2019, just to give you a little flavor of some of the work that we're continuing. Last legislative session, we received another $1.5 million to continue urban stormwater research. We've already assembled $115,000 in leverage funds on that. And what we did is we launched a request for research proposals that happened in early December of 2019, and we're currently just reviewing all those new research proposals. But a whole number of new research projects will begin this year, as those from 2017 and 2018 are now completed. Last July, we had our first really big, what we call full Minnesota Stormwater Research Council meeting, where we try to gather as many professionals and policymakers from across the state. And we brief them on the different research programs and projects that are happening. So we do this at St. Anthony Falls Laboratory. It occurs both inside and outside. You can see that in this picture. And the other big success from 2019 is we actually hired full-time capacity to lead these research programs. That's me, but it's not the emphasis of me. What I wanted to really emphasize is that the Water Resource Center and CFANS recognize that the urban stormwater research portfolio continues to grow, and that we're going to invest time, talent, and money in making sure the research gets done, it gets done correctly, it gets done timely, and we can keep building from one research project to the next. So big successes. I think lastly, what I want to cover is what's coming out of the pipe for 2020. By the way, what's pictured here is what we refer to as a stormwater outfall. This particular one, believe it or not, that is 8 feet in diameter. This particular outfall drains all of Northeast Minneapolis. So perhaps you've been Northeast Minneapolis for dinner or restaurants, and shopping, drinking, what have you. Most of the impervious surface in Northeast Minneapolis and the water, snow melt that occurs there comes out of this pipe in the end. In a 1-inch rainstorm, in less than a half a day, this pipe will fill at least halfway full. I've seen it. larger rainfall events, you have 8 feet of water coming out of this pipe. This is a lot of urban stormwater runoff from one particular part of Minneapolis, just a small piece as an example. So to tackle some of those issues that come out of that stormwater outfall, this is what's happening in 2020. So those research projects that I gave you a quick brief on, all of those are going to finish here in the next few months. Some of those finish by the end of March, the rest of the 6 finish in June. We will take the results of those research projects and begin to integrate them into coursework here at the university, also extension workshops and other certification workshops that happen across the state with professionals and practitioners. As we do that, we're going to take some time to reflect on what is effective education and training. And we're happy to announce that probably next week, we're going to launch a search for a brand new position, a full-time position for what we call an urban stormwater educator that will help us get this information out to communities across the state. As I mentioned, we're currently reviewing new research proposals for 2020, and I anticipate sometime within the next month, we will fund between 7 and 12 new research proposals, looking at some new creative problems and questions that we have. And we've already scheduled our July 16th council meeting at St. Anthony Falls Lab. This is where you can hear about some of the research results and about the new projects that we're implementing this field season. And then last but not least, probably our biggest event of the year is the Minnesota Water Resources Conference that occurs October and 13th and 14th of every year. It's the largest water conference in the state. If you haven't participated, we have more than 800 participants. But this year we will have a special stormwater session track that will feature a lot of this research that we're doing as part of this program. All right, so with that, I'm going to end, but I'll just remind you. So this all grew out of stormwater research needs, which is reflected in this brochure. It's called the Stormwater Research Roadmap for Minnesota. You're welcome to take that with you. And then a lot of what I talked about is covered in this colorful brochure, which is basically a brief of our program over 2 years. Our 2019-2020 version of this will be available in about a month. But it provides a lot of that background information, including the list of all 11 projects. And if you want to know more about those projects, I really would encourage you to take a look at the website, which is on those materials. It's also up here on the screen. But we have an individual page that highlights each of those research projects by themselves. So with that, I'm going to end my thoughts about the Stormwater Research Program. I'd certainly entertain some questions if you have them. And thank you for having me. Questions, thoughts? Yes, sir.
I'm actually a watershed commissioner for Shingle Creek.
Yeah.
And so we review projects all the time that have to meet stormwater runoff rules. You know, you have to mitigate runoff from 10-year storms and things like that. And so on a project by project basis, people all over the Twin Cities area are doing the same thing. But my concern has always been that nobody's looking at the cumulative effects of all these projects that are going in. And nobody's really addressing the issue of, like, what should our cumulative, you know, stormwater runoff goals be as a metro area?
Mm-hmm.
Do you think that's an issue that would be worthwhile to consider, or what?
Yes. A number of things have been proposed on that at different scales. And there's certainly a need for that. I think we're going to fund a project or two that looks at that, but let me first talk about the scales. There's been some need and work identified to look at what are the impacts, let's say, of stormwater reuse systems, not by a city, not by an individual reuse system, a cistern, but a whole series of them, or what impact are they having across the state or the whole metro area. So that's a scale in terms of individual practices. Another need that has been identified, and we're considering a proposal on this right now, is to look at the quality of runoff coming into rain gardens, bioretention basins, and that leaving, but not at one basin, not 6 basins, not 12, but collectively across the state or across the metro. So metadata analysis of rain gardens is one example. And there's a few others that are kind of along that scale, but what you're speaking to is what we've been referring to as meta-analysis. How can we look at all the different sampling that we're doing, not by an individual practice, not by an individual city or an individual neighborhood, but collectively? There are some challenges there in terms of what quality is the data, different scales it's been collected, different methods, but we're working on some of those things. Other questions or comments?
I'm curious about the street sweeper program you mentioned. I'm just wondering how you developed the partnerships with those four.
Well, I wasn't involved in the research that's doing that, but it's really about the researchers working with stormwater professionals in the communities. Some of that happens through the Stormwater Research Council. Some of it's about just knowing different professionals in the different fields. In this particular case, working with the manufacturer of different street sweepers and where did they sell those street sweepers and in what communities. So all of this is aligned. So it's a lot through partnerships and communications and networking. And I keep mentioning about this applied research in communities. It's about finding local community partners, Public Works or MnDOT, those types of people that want to work with you, that can work with you, have the capacity, not only the expertise, but will do quality work that supports research. So. Yeah.
You talk a bit about
Say that again.
Can you talk about some of the benefits and challenges of working with
Yeah. So the question is about working with the diverse Stormwater Research Council members, right? The diversity of the council members is what makes the program strong. Not only the diversity of the council members, but the diversity of the communities and the professions that they represent. So the Research Council, our advisory board, for example, is 21 members. We have 5 city representatives from different sizes of cities. We have watershed district representatives. We have a few agency representatives. And we also have private enterprise because we have a lot of private engineering firms that do a lot of work in stormwater management. So actually, this diversity of having a lot of different people, different opinions, different information at the table works to our benefit. It helps us make sure that we're doing the research that's most needed and can be the most used or used by more people. It's all about where this work can be used in more communities, in more places, by more people across the state. So diversity works to our favor. Anything else?
Yeah, I think we had another speaker talk about, you know, the infrastructure that exists for conveying stormwater and how that's getting out of date with regards to climate change. So what is the Stormwater Research Council's thinking about, you know, the effects of climate change on our infrastructure and its ability to handle intense storms?
Yeah. So not the Research Council, but the university, state of Minnesota, different agencies have invested a lot of money looking at climate predictions for the future and what impacts that has on stormwater infrastructure. So let me break that down. Climate predictions for us mean more severe storms more often, which means more urban stormwater runoff. Now, that's oversimplifying it, but that's that piece. The infrastructure we're talking about are pipes under the ground, roadside ditches, stormwater ponds that collect some of this water. So that's infrastructure. And so the infrastructure that you might be familiar with, or you might look at when you leave the room here today and on your way home, much of that infrastructure was built 20, 30, 40, 50 years ago under a different climate, under different precipitation patterns, under different engineering guidelines. And because the rainfall patterns are changing, the infrastructure was not designed to take this much stormwater runoff. That's part of the precipitation changes that we're seeing. It's also having to do with land use changes. We continue to develop the urban landscape. The Twin Cities continues to grow. We add more parking lots, more Walgreens, more Targets, more impervious surface. So we have more runoff from impervious surface, and we have more precipitation, so we have more runoff. It's a double whammy. So a lot of work has been done looking at what the climate predictions are. Some work has been looked at in terms of what does that mean for stormwater infrastructures? How does it, what we call surcharge the system or overwhelm the system? The work that's needed next is how to provide that type of information down to the local level. Because in the end, who manages stormwater infrastructure will be individual cities. So we know what the precipitation patterns look like at the state level and how they're changing. We even know a little bit at a smaller scale. We need to get that down to a level that cities can see, understand, and use so they can assess their stormwater systems. The challenge with that is most of this infrastructure is under pavement, it's under buildings in some cases, it's under parking lots. They're very expensive to excavate. And so it's not an easy solution. It's not something we do next year. We have to look 10, 20 years down the line in terms of how do we mitigate the impacts to this infrastructure system that can be overwhelmed. Long answer to that question. Any other questions or comments?
Thank you very much.
Thank you.
Have a good spring break, everyone.
Andy and Vinny, you came over just to hear what you know.
Hi.
Oh, where?